So yes, I am. I'm recording you guys today. I'll go ahead and let you know that the goal in today's lesson is to review our last two methods of factoring. AC grouping, and then I have a little bit of a shortcut to show you for when A is 1. In other words, when there's no number in front of your x squared, there's a little bit of a shortcut you could take. So we're going to review those with you today. What I have highlighted up here, because it's not there for decoration, is kind of a little insight into how that shortcut could work out for you. So I'll come back in just a few moments towards the end of our lesson today to kind of talk with you about why those numbers are highlighted up there. So with that being said, the methods we're going to use today pretty much all deal with quadratic equations that are written in what we call standard form. And maybe think back to your experience in Algebra 1. In general, they define for you there what standard form for any polynomial is going to look like. And characteristically speaking, you might recall from your Algebra 1 or maybe even your geometry class that when we write a polynomial in standard form, we look at the exponents and they decrease as we go down the line. Do you remember that a little bit? Yeah? Okay, good. So when we go to write a quadratic in standard form, that sort of rule that you had for polynomials in Algebra 1 follows in line here. So when we have a quadratic written in standard form, it's always going to look like y equals ax squared plus bx plus c, where a is a coefficient of x squared. Coefficient, by the way, just means number in front of a variable. B is the coefficient of x, and c, I always think in my head, c stands for constant, something that doesn't have a variable attached to it. This would be just a number on the end of the problem. Why that's important is because if we're going to use something called the AC method, it's important to have your quadratic written in standard form so that you can correctly identify what number is A, what number is C. So it's helpful for you to always try to write your quadratics in standard form first. So as we look at example 1, this is the quintessential case where AC grouping would be nice to have so that we could factor that quadratic. The question here asks us to factor 6x squared plus 17x plus 5. And right now, my eyeballs notice that that is a quadratic in standard form. My decreasing order of exponents is what I see in that problem. It goes x squared, x to the first, and then a constant on the end. So identifying A and C is pretty straightforward. I know that A is always the number in front of our x squared, so A in this problem is just going to be 6. C is just the constant on the end, and I notice our 5 is in the spot where our C is, so C in this problem is 5. And in step 1 of the AC method, you multiply A times C. So A times C for us is going to be 6 times 5. 6 times 5 is a product of 30. In step 2, I then have to ask myself, what are the things that multiply to give me 30, but then add to my B value? Things that multiply to give me 30 are factors of 30 that would add to my B value. So now I have to kind of think to myself, well, what's B? So here's me thinking, my thinking cloud there, and I'm thinking right now about B. B in this problem, B is always your coefficient of your x value. So B in this problem is 17. So right now I'm thinking to myself, what are two numbers that multiply to give me 30, but when I add them together, have a sum of 17? I'll repeat the question so that everybody has a chance to think about it. Lots of hands in the air. Good job, guys. Quick on your feet. Smart group of people. All right, so we're thinking of numbers that multiply to give us 30, but then have a sum 17. Go, Tamara. 15 times 2 gives us a product of positive 30, and then the sum of positive 15 and positive 2 is positive 17, so nice job. She's right about that. Anybody have any questions about how Tamara came up with 15 and 2? This is the one place, I'll be honest with you, in Algebra 2 where guessing and checking is okay. So, for instance, you might have said 6 times 5. Well, 6 times 5 sure is 30. But 6 plus 5? Oh, that's 11, not 17. The most common mistake I'll see with regard to this particular step is with signs. So just be cautious of that. If A times C is a negative product, well then you're going to have one factor that's negative and one factor that's positive when you're going to list those out. So just a little heads up on that. In step 2, you'll see I'm not done yet. I did think of the numbers that multiply to AC that add to B, but do you see how I have in big, shouty capital letters here? We have to rewrite the original expression. The idea here is that we're AC grouping for our lesson. Oh, thank you so much. I appreciate that. All right, so with that, do you see how I had 3 terms in the original expression? I'm now going to attach X to those there, and I'm going to take what was 3 terms and write it as 4 terms. So I'm going to bring down the 6x squared and the 5 from the original problem, and all of these things were positive. In algebra, we work really, really hard to preserve equality, and it sounds like a social studies lesson, but I'll go ahead and let you know that it's common in algebra class that your third step down should be equal to your second step, and your second step should be the same as the original problem. So you kind of want to just think a little bit about that. When I look at this 4-term expression, it should be precisely equivalent to the original trinomial. So let's just check that real quick. So 6x squared plus 15x plus 2x, these are like terms in here. 15x plus 2x does give me 17x. So far so good. Plus 5, oh look at that. It totally matches up. This 4-term expression right there is the same as the original trinomial. Some of your teachers called this maybe last year AC grouping, because first you do AC, and now that we have 4 terms, we can group it right down the middle. So what we're going to do is, this is not an official thing I'm about to write, it's just the way I group things in my head. I have 4 terms here, so I'm going to pull a little squiggle down the middle. Watch out if that's a negative, you don't want to like knock that negative out, but I'm just going to kind of group it by looking at my first 2 terms and my last 2 terms. And step 3, this is actually factoring by grouping. I group my first 2 terms together and my last 2 terms together. When I do this, I can now take the GCF of 6x squared and 15x, and I could take a GCF out of 2x plus 5. This is the grouping part. Need a little help. GCF of 6x squared plus 15x. I need the GCF of those 2 terms right there. Go ahead, Michael. Yes. So if I pull a 3x out of here, what's left over is 2x plus 5. And then I still had a squiggle there. $2x plus 5, I need a GCF out of that right side. Is there a GCF? No. Well, there is. It's 1. And that's a plus sign that was in there, so I just kept that plus sign there. So the 2x plus 5 can follow down there. Because 1 times 2x plus 5 will get me back to the 2x plus 5. Remember, it has to be equal. So I had to pull out a 1. If there's not a GCF to pull out, lesson learned right now, pull out a 1. Okay, then something magical happens. Sometimes being good at math is up here one of these behaviors, right? Utilizing a pattern. Do you see a pattern in what just came out of here? It's 2x plus 5, right? That's not a coincidence. That should always happen. You should get that set of repeating parentheses. What's nice to note at this point in time, I'm going to get rid of my squiggle here for just a second. This was the expression that I had, equivalent to the 4-term polynomial above it, right? What I'm actually looking at in this problem right now is a big term here and a big term here. Do you see that? Big term on the left side of this big plus in the middle. Big term on the right in blue there. I could actually do the GCF method again. So see this thing I highlighted in yellow right here? That is now a GCF in this bigger polynomial. So I GCF method again a third time to pull this highlighted chunk out of my problem. If I take this 2x plus 5 out, now I need to write what I have left over. 3x plus 1 would be what I have left over. So it's in this way, you know, if I think about how I distribute, this is actually a different way of foiling binomials. I could just take this and distribute it to this term and to that term. Pretty interesting, right? It's another way of looking at it. So in effect, all I did in this last step here, was I pulled down the set of parentheses that repeated as a GCF, and then I wrote what I had left over. And that's it. It's factored. All done. You folks know that you're always responsible for attending to precision. So we do have to check with FOIL. We want to make sure we did it correctly. So I'm going to check it with some FOIL. 2x times 3x is 6x squared. 2x times 1 is 2x. 5 times 3x is 15x. And then 5 times 1 is 5. When I combine my like terms in between, I do get 17x plus 5. And then if I look at that, I'm a pretty happy camper, because that matches my original problem, which means that this is indeed the correct final answer. I'm pretty happy about that. You do not need to write all those smileys down. Oh, boy. That was really funny. Alyssa, what's up? Okay, so at what point, here or here? The one in smiley faces. So you understood this line right here, is that correct? Okay. It is just a greatest common factor. So when you pull out a greatest common factor, what do you always write in those leftover sets of parentheses? It's basically just the distributive property, like I said before, in reverse. You just write what's left over after you pull out that GCF. So this thing highlighted in yellow was a GCF, so I pulled it out. And then I had to write down what I had left over, which in this case was a 3x and a positive 1. Oh, good. I'm glad I could help. I was worried about that for a second. I was like, what? All right, we're going to do it again. A little bit of practice. So the difference between this example and the next example, no chart. Taking the training wheels off. You can, of course, flip back to the chart if you need to. Some of you have done this quite a bit before in your past math classes. You can definitely work ahead. Just periodically glance up to make sure you're on the right track, okay? So here in example 2, we're factoring 2x squared plus x minus 6. Step 1, be careful. You take out a GCF, if there is one. Did you look for a GCF, or you're not a robot. You don't just do your A times C right away. I know that that's the method we're going after today, but step 1 in every factoring problem is to take out a GCF. I don't see one. Do you? No, there's not one there. If there were a B value, like a number in front of that X that were even, you could pull out a 2. But now we're just going to jump right into it. There is no GCF, so I am going to do A times C. A times C. 2 times negative 6. That is negative 12. I'm right now thinking about things that multiply to give me negative 12, but then add to a B value of 1. Coefficient of X in this case is 1. Little help with that. I know some of you are cruising along. What'd you come up with? Things that multiply to give me negative 12 that add to 1. Go ahead, Dawn. Yes. Watch your signs. That's usually the mistake I see in that step. The product of negative 3 and 4 is definitely negative 12. And then negative 3 plus 4 is positive 1, so it does work out. Keep in mind, if you wrote 4 and then negative 3, multiplication is commutative, this still works. So if you wrote it backwards, you're okay. All right, now I'm going to go ahead and attach an x to each of those factors. And then I bring down the rest of the problem all around it. This is where we transition from the AC part to grouping. I have to take what was 3 terms and turn it into 4 terms so that I can group 2 terms and 2 terms. So I have 2x squared coming down from the original problem. Negative 3x plus 4x would give me the 1x. And then I'll bring down my minus 6. I group the first 2 terms together and the last 2 terms together. So if I take a look at the first 2 terms, I see a GCF. Right now, looks like they have an x in common. And then 2x minus 3 would be what I have left over. On the right side of my squiggle, take out a 2 there. And then I see that I have 2x minus 3. And you're always going to get this set of parentheses that repeats itself. Moving my squiggle here for a second. Bring down that plus sign. And all I'm doing right now is that GCF method again. I see I have this 2x minus 3 that repeats itself. That's now a GCF in this bigger polynomial, so I can factor that out. So I'll factor out the 2x minus 3, and then what's left over is x plus 2. And then I check it with FOIL. I think I did it right. Pretty sure I did. So 2x times x is 2x squared. Outers is 4x. Inners is negative 3x. My last is negative 6. Simplify this. Hey, look, it matches. I'm pretty happy about that. So I know I got the right answer there. There questions about it? Okay, so now you get to try a little bit. Now that we've done 2 together, I'd like you to try 3 of them. And I'm going to walk around and kind of help you out a little bit if you need it. Okay, so if you're still working on your first independent practice, those 3 problems, keep working, do not look up. Some of you are now done with it. I did want to give you the chance to check it, and then you could kind of draw your attention a little bit to your homework, not too much because I have a shortcut to show you. Maddie actually already knows the shortcut. But I just did want to give you a minute to check your independent practice if you're done, and then you could start looking at your homework for tonight. I have a shortcut to show you still, so don't get too buried in that homework. If you're still working on your independent practice, I want you to keep working. Don't look up just yet, but if you're done with it, there it is. So I do have a little bit of a shortcut for you, and it comes at you in this last example of our day. The shortcut, just to be clear, can only be used really in one case. If you take out a GCF and what you're left with is just this x squared all by itself, no number in front of it, this is where you could use the shortcut. Or if your original problem just starts with an x squared or a p squared, no number in front of it, you could actually use a little bit of a shortcut. So you don't have to do AC grouping, make you a little faster. So here's how this is going to look. First, it should be noted the case that it's not that there's no number in front of the x squared. There's a 1 in front of the x squared, right? So A in this problem is 1. That is the case we're talking about right now, where your leading coefficient is 1. B in this problem is negative 7. C in this case is 12. Now, imagine you're going through your paces and you do AC grouping. You're taking 1 times 12 to think of the numbers that multiply to give you 12 that add to negative 7. That 1 doesn't even really play a role. So I say just ignore that, because it doesn't play a role. Multiplying by 1 doesn't do anything to our C value anyway. All you're going to do, the shortcut, is to think of the factors of C, just C, that add to B. So let's do that for a second. Right now I'm trying to think of numbers that multiply to give me C, which is 12, but then add to my B value, which is negative 7. What are the numbers that multiply to give me 12, but add to negative 7? Good, Denise? Yeah. And the order doesn't matter. So instead of now attaching an X and writing it as 4 terms, here's my shortcut. You know that we're basically stuffing sets of parentheses here with the exception of the GCF method. The numbers that are going to be your lasts have to be negative 4 and negative 3, because negative 4 times negative 3 would get you back to this positive 12 here at the beginning of the problem, right there. And then you kind of think to yourself, well, what has to be out in front? These are things that had to multiply to give us x squared in the beginning, right? If we're essentially unfoiling, well, what multiplies to give you x squared? X times x. So that's a little bit of a shortcut for you. You're done. It's a lot less steps. So in general, our shortcut is just to look at the C value. Think of the things that multiply to give us C, but then add to the B value. Remember, you can only really use this shortcut when your A value is 1. If there's a number out in front, you either have to take it out with a GCF or AC group. Am I clear about that? You can check it with FOIL. This does work. That'll save you some time on your homework tonight, because there's quite a few problems that have an A value of 1. To be clear, you're doing that factoring worksheet 1 to 18. That's what you're doing tonight for homework. You do have a quiz in our next lesson, so you'll want to keep that in mind. So you're going to go back through your notes a little bit to study the 2 methods we did yesterday. Maybe take another look at that homework assignment from last night. And then these problems that you have here are practice with AC grouping or a shortcut, and that's what you're going to have a quiz on when we get back together. Okay? You do have a couple of problems you could try in your notes, or you could take some time to try some on your homework. As long as you're wrapping up today, giving yourself a little bit extra practice while I'm around, that would be a wise way to use your time.